bridge pattern is a commonly used structural pattern from the well-known Gang of Four design patterns. They describe the intent of this pattern as to decouple an abstraction from its implementation so the two can vary, in other words, be developed, be changed, independently. As with all these intent definitions, this requires a bit more explanation. You could rephrase this as this pattern aims to separate an abstraction of the class from the implementation. As a result, this provides the means to replace an implementation with another implementation, without modifying the abstraction. Abstraction in this context can be seen as a way to simplify something complex. Take, for example, a console app that wants to write something. Console.writeLine is an abstraction to whatever is contained within the writeLine method. So every action and function, for example, are abstractions. We're constantly using and creating them. Abstractions thus handle complexity by hiding the parts that we don't need to know about. And this abstraction is what we're trying to decouple from its implementation. When I hear things like separate abstraction from implementation, I'm immediately thinking about interfaces and abstract classes. Yet it's a bit more complicated than that. Let's clarify this with a real-world example. Say we're creating software for managing a restaurant register. There's two menus available: a meat-based menu and a vegetarian menu. Both menu implementations expose a method, calculate price. Depending on the menu, other fields are available, but those are not of interest for us right now. So, the class that needs to add up the total amount owed can simply call into calculate price on each menu. We could implement this with an abstract base menu class or with an iMenu interface. Now imagine that we're introducing something new, a coupon. One that offers a €1 discount, another one that offers a €2 discount, and so on. These affect the price of both our menus, obviously. How do we implement that? Well, one way of doing that might be to create additional menu specializations, deriving from meat-based menu. Meat-based menu with €1 coupon, meat-based menu with €2 coupon, and two more, deriving from vegetarian menu. Vegetarian menu with €1 coupon, vegetarian menu with €2 coupon. I don't know about you, but this does not look ideal to me. Imagine that another menu is added, vegan menu. We'll have to create additional subclasses for that as well. Or imagine another coupon value being added. We'll need a new subclass for each menu. So as you can imagine, approaching it like this, by adding subclasses, leads to many additional classes and complexity. That is unnecessary and something we want to avoid. And that's where the bridge pattern comes in. We're going to put the abstraction, which is the meat-based menu and vegetarian menu, i.e. the ones based on the menu abstract base class, or the iMenu interface, in one hierarchy. The abstract base class contains the definition of calculate price, and meat-based menu and vegetarian menu implement it. But to be able to calculate the price, our menus need to know the coupon value. These are named implementers, which we can put in a separate hierarchy. So we'll have a coupon abstract base class or an iCoupon interface, which states that a coupon value must be exposed. And then we have implementations of it, €1 coupon and €2 coupon, who expose the actual coupon value. Each menu then needs access to a coupon on which it can calculate the coupon amount when calculating its price. And we can do that with a bit of composition. The abstract base menu class will require an abstract coupon object, or something that implements the iCoupon interface. As that states that there should be a coupon value that can be accessed, the correct price can be calculated. That relationship between the menu and the coupon, that is what is named the bridge, as it bridges the abstraction and implementation, letting them vary independently. From this real-world example, we can now extract the structure of this pattern